In CWARs, detecting palindrome numbers involves reversing the digits and comparing them to the original number. This algorithm is crucial for technical interviews and data validation. Implementing it requires understanding loops, conditionals, and string manipulation to ensure accurate symmetry detection. A palindrome number reads the same forwards and backwards, like 121 or 12321. These numbers are perfect mirror images, making them a key focus in coding interviews. Understanding palindromes tests your algorithmic skills, numeric manipulation, and logical thinking, crucial for problem solving in major tech companies. Palindrome checks in C# are crucial for data validation, ensuring numeric input integrity and identifying patterns in financial systems. They test algorithm mastery, requiring number manipulation, loop understanding, and clean logic. Mastering palindromes enhances skills in string manipulation, numeric operations, type conversions, and efficient algorithm design, essential for every C# developer. The palindrome detection algorithm involves 4 steps. First, store the original number in a temporary variable. Next, reverse the digits using modulo and division operations. Then, compare the reversed number with the original. Finally, return the result. If they match, it's a palindrome. If not, it isn't. The reverse number method in CDR efficiently checks palindromes using numeric manipulation. It extracts digits with %10, builds the reversed number by multiplying by 10, and compares it to the original. This method operates with a time complexity of O log n and space complexity of O1, ensuring optimal performance.